Hello students, today we are going to start new topic solid state. Okay, so solid state, there are different states of matter, right? We have seen in lower classes solid, liquid, gases. Here we are talking about solids. So what are the characteristics of solids? So we studied already, solids have definite shape, solids have definite shape, definite volume. Okay, second one is intermolecular force of attraction is very strong. They are very rigid. They are rigid. Intermolecular force of attraction is very strong, very strong. The space between the particles or space between the particles are less, like this. You might have studied so many points already in lower classes. Okay, they are very hard, they are very rigid. Some exceptional things, exceptions you might have studied. Now we are going to see how the solids can be classified based upon nature of arrangement of particles. Okay, the solids can be classified into two types. One is called crystalline solids. Second one is called amorphous solids. Amorphous solids. Okay, so what is crystalline solids? Suppose for crystalline solids, they have very good example is sodium chloride. Sodium chloride, crystalline solids. Crystalline solids. Here some terms we should understand. Another one is called amorphous. Amorphous solids. In crystalline solids, the particles, they have regular arrangement throughout the crystal. Okay, suppose for example this is the crystal, they have particular orderly arrangement throughout the crystal, then we call that is crystalline solid. So the arrangement continuously goes from one area to other. This means as a whole, in the whole structure they have regular arrangement. So we can call it is a long range order. It is a crystalline, they are long range order. Long range order. In amorphous, actually they don't have regular arrangement of particles. In some area some arrangement will be there. After that, that is irregular arrangement. So we can say that arrangement doesn't go for long time. Okay, not throughout the crystal. So suppose for example this is a crystal amorphous, some area some arrangement, again if you see they have different arrangement. So we call it, they have short range order. Short range order. Amorphous solid, you can give example sodium chloride, quartz, etc. Here you can tell rubber, glass, plastic, etc. Plastic, etc. Okay, they have regular arrangement of particles. Okay, the next one is, suppose for example these solid crystalline solids, they are known as true solids. Here they are called as pseudo solids. Pseudo solids. Suppose glass and everything you see, in glass what happens sometimes, suppose this is a glass piece or window panes or something, this is a window panes. So if you observe that one, in some cases you can see the top of this one is very thin in nature. But when you observe that bottom of this one, it will be very thick in nature. Okay, this I have observed when I was very young in our ancestors' house. Okay, so that window panes are made up of purple color, dark red, bottle green, like this color. But the top of this one, it is very thin sheet like that. The bottom of the window pane means bottom of the glass, no, in window pane. Window panes actually here frames will be there, and here it's made up of glass. So this area like this one, it will be very thicker, much thicker than the previous one, because they flow from, normally we studied this one, liquid and gases, they move from one, they can flow from one place to other. So they are known as fluids. So like this, they are also due to gravity, the particles migrate from top and to bottom. So like so this quality they have, so they are known as pseudo solids. Then crystalline solids, they have definite shape. Crystalline solids, they have definite shape. Definite shape. Here no definite shape. No definite shape. Okay, here we can see which one, they have clear cut cleavage. Clear cut cleavage. Here they do not have clear cut cleavage. They do not have clear cut cleavage. Clear cut cleavage. So if you understand now, suppose for example, just imagine a bakery, their sliced bread is there and unsliced bread is there. So sliced bread, no, so for slicing they use one particular knife. So with that knife they cut this one bread. So you get exact sliced bread, good looking, it is very, you can say it's one proper arrangement like that. So just imagine that one, if you take crystalline solid, if you cut it, you get like a slice, you will get one piece, regular arrangement, like one piece you will get. So we can get one, that is clear cut cleavage. But here do not get clear cut cleavage. So what is, they do not cut, suppose say unsliced bread, if we bring it to our house, then you start cutting that one. So what happened this time, we don't have the particular knife, so it will come like this one, not clear one, like somewhere broken, somewhere powdered like that. So that is not clear cut cleavage. Okay, so next one is, next very important points are, they have high melting and boiling point. They have high melting point and boiling point. Here they have low melting point and melting point and boiling point. You see here they are closely packed on particular order. So if you have to melt it, what happens, this one, that order has to be broken. So you have to apply more and more temperature. Here is somewhere it is not, particles are not there, somewhere particles are there. So they have low melting and boiling points. Next one, these crystalline amorphous solids are isotropic in nature. Isotropic in nature. Okay, here crystalline solids are anisotropic. Normally students, they get confused. They write anisotropic for amorphous solid, isotropic for crystalline solids. So for example, you see in crystalline solids they have orderly regular arrangement. So this one here, next particles, the next particle, suppose it is coming here like this one. So we cannot actually, we are assuming they are spherical molecules, spherical atoms are spherical. So just you see this one, suppose we are taking this distance, this much. Next distance you see, suppose this distance. So this is x, this is which one, y. The distance between this particle, suppose this is A, this is B, this is C. So AB distance is x, AC distance is y. So what is happening, they are not same distance. So their physical properties like refractive index, electrical conductance, or you can tell which one, refractive index or electrical conductance, like that same properties, they are different in different direction. They are not same in all direction. So they are different because molecules or particles are, they are arranged in orderly manner. So the distance between the particles are different. So they have their physical properties like refractive index. They are refractive index. They are different electrical conductance. They are in different direction. But in case of anisotropic particle, anisotropic in crystal amorphous solids, the particles are not in orderly arrangement. Like that, okay? So not in orderly arrangement. So the properties are same in all direction. So that is called isotropic. This is anisotropic. So this what is long range order, very important point. What is true solids, very important point. What is clear cut cleavage is important point. Then isotropy and isotropy, that is very important. Then if you see heat of fusion, they have definite enthalpy of fusion. Okay, what is heat of fusion? Enthalpy change, the amount of enthalpy required for melting that one. So they have definite, here they do not have definite. So here they have definite enthalpy of fusion. They have definite enthalpy of fusion. Enthalpy of fusion. Okay, next one is they do not have definite. Here they do not have. Okay, so this is based upon arrangement of particles in the solids. So this classification is amorphous and crystalline. Amorphous means no form. Okay, so next one we are going to another classification based upon the intermolecular forces acting in the solids. Okay, so what is the different intermolecular forces acting in the solids? Based upon solids are classified into 4 types. So this is based upon nature of arrangement of atoms. Second one is based upon intermolecular force of attraction. Right? So first one is number 1, based upon classification based upon intermolecular force of attraction. Number 1 is ionic solids. So we classify them. Number 1, ionic solids. Second one is covalent solids. Third one is metallic solids. Fourth one is called molecular solids. In molecular solids, polar solids are there, non-polar solids are there, hydrogen bonded solids are there. So first one we can go to ionic solids. Ionic solids already you might have studied in different lessons. Even chemical bonding, it is also there. Ionic solids. Ionic solids, very good example, NaCl, KCl. Okay, here intermolecular force of attraction is this is actually positively charged ion and negatively charged ion. So Coulombic force of attraction or electrostatic force of attraction that binds the atoms together. So intermolecular force of attraction is electrostatic force of attraction. Electrostatic force of attraction. Second one, here Na plus here Cl minus. So here particles are in ionic solids, particles are ions. They have high melting point and boiling point. They do not conduct electricity in high melting point and boiling point. Next one, they do not conduct electricity. In solid state. solid state, they conduct electricity in molten or aqueous state. Okay, they are hard and brittle. Now next one, we can go for covalent solids, right? So in covalent solids, very good example, you can tell graphite, diamond, SiO2, all these things, they are example for covalent solids. So they are covalently bonded atoms. There, what is the bonds they are acting? That one, that is covalent bond. You see, covalent bond. So there is this one, covalent solids. Okay, example, you can write this one, diamond, graphite, SiC, etc. Covalent solids, covalent bonds. So here each particles are, suppose you might have studied diamond. Diamond, what is the structure of diamond? Each carbon atom is tetrahedrally connected to 4 different carbon atoms. You see, normally covalent solids when compared to ionic solids, they have low melting and boiling point. But here what is happening here? They have, in diamond, they have high melting and boiling point. Okay, because each carbon atom, if you see diamond, each carbon atom tetrahedrally connected to 4 different carbon atoms. So they are very strong, they high melting and boiling point. Next one, covalent solids, normally they do not conduct electricity, right? So they do not conduct electricity except graphite. You see, in carbon here, in diamond, each single bond, they have each one. Here what is happening in except graphite? Graphite, what is this one? You studied that one. Their structure is like different layered structure. So just imagine there is a hexagonal structure. So 1, 2, 3, 4, 5, 6. So it is like this, one atom here. So it is connected to different hexagonal structure. As a result, what happened? This one, they form different layers. So the structure itself is one. Each carbon atom is connected to 4 other carbon atom. Okay, their valence electron, you see 4 valence electron, their 1 valence electron is free. So what happened? This one, they goes on moving. As a result, the graphite, it has which one? Layered structure. The layered structure, this is one layer, this is another layer. In between the free valence electron, it moves that one. So that is mobile electron. Due to this mobile electron, they act as a good conductors. Okay, and here layer structure now, so one in between they have gap, so one layer can slide over the other layer. So because of this property, graphite can be used as a lubricant. So what is the use of graphite? Graphite can be used for making electrode, and graphite can be used as an lubricant in industries. Okay, the next one, we can go for metallic solids. Metallic solids, I think in chemical bonding we had studied this one, metallic solids. So metallic solids. Here the bond in metallic solids are metallic bond. Example, metallic solid, copper, Au, Ag, etc. All metals you can tell. Okay, mercury, normally they exist in solid state, but mercury in liquid, in gallium, at room temperature they exist as liquid. Okay, so if you see metallic solids, you see, suppose sodium. So sodium metal 2,8,1. So if you see this one, this is nucleus. Then this is first shell, 2 electrons. Next shell, you see, already we studied this one, 1, 2, 3, 4, 5, 6, 7, 8 electron. So outermost 1 electron, that is valence electron. Okay, this nucleus we already studied one nucleus plus this other electron means 10 electrons. Nucleus plus 10 electrons, they form positive, that is called positive kernels, KENEL, positive kernels. Then outside this valence electrons are there. So there is, suppose one atom, one valence electron. If you take a metal, there are n number of atoms. So n number of what will be there? Valence electrons will be there. So this valence electron and this positive kernel, they have strong attraction. As a result, they act as a very good conductors of electricity. Okay, so that is a metallic solids. Next one, we are going to study about molecular solids. Molecular solids means here the particles are molecules. Okay, number one, polar, non-polar solids. Molecular solids, molecular solids, molecular solids. It is further classified into non-polar, like I2, H2, O2, etc. Next one, polar, example ammonia. Okay, the next one is, third one is hydrogen bonded. Hydrogen bonded. Example ice. Ice is solid of water. Solid form of water is ice. Solid form of water is ice. That is hydrogen bonded. Okay, so first one, in non-polar solids, you see the force of attraction between them is equal to this London forces. You might have studied in states of matter, London forces. The name of your scientist. Next one, polar. You know what is polar and non-polar? You might have studied in first year. Here you see H and H. Here electrons, here also electron. So non-polar, same force of attraction, here also same force of attraction. So dipole moment will be 0. Then there is non-polar molecules, right? So here attractive forces, intermolecular attractive forces, London forces here. In polar molecule, N, H, H, H here. So this is actually here lone pair. So their force of attraction is dipole, 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 dipole interaction. Okay, what is dipole, dipole interaction? Dipole, dipole interaction, it occurs only in polar molecules. For example, you see, just I am giving another example of HCl. So HCl molecule, what happened? Dipole means H is here, Cl is there here. So due to, so already basically they are polar. So this is delta plus, here delta minus. So then dipoles are made, two poles are made, means it forms here. So one side positive, another one, what is a negative. Then another also one dipole. So dipole, it is coming here, means what will be here also H, delta plus, delta minus. So this molecule interaction, that is dipole, dipole interaction. Another one is hydrogen bonded. Hydrogen bonded we studied already. What is hydrogen bond? The bond formed between hydrogen and highly electronegative atom like fluorine, oxygen and nitrogen. Fluorine, oxygen and nitrogen. So what is hydrogen? Hydrogen can form bond with highly electronegative, periodic table, highly electronegative. To remember this one, now you can remember phone. So fluorine, oxygen, nitrogen, they form bond with these atoms. So that is hydrogen bonded. So ice, you see, ice, what is happening? Which one? This is H, water. Same water molecule, but another water molecule, OH. So this is one water molecule, this is another water molecule. Both the water molecules are connected by hydrogen bonding. So their attractive forces here hydrogen bonded, here dipole, here what this one? London forces. Okay, this is today just one introduction only. You can go through the NCERT book and still you refer these points also. Then it's a generalized idea. Okay, so first we have seen solids can be classified into two types, amorphous and crystalline. Second one is based upon intermolecular forces, ionic solids, molecular solids, ionic solids, covalent solids, molecular solids and metallic solids. Remaining thing we'll see in the next video. Okay, thank you.